Welcome to this talk to the expert session, where we explore the latest HAI use cases and key features of the Barbara platform. I'm Miren, Head of Marketing at Barbara, and I am joined by Enrique Ramirez Quique, our solution architect and technical expert. Today, we will walk you through how Barbara can be used to implement a unified namespace architecture in a multi-site food and beverage company. Hi, Quique. Great to have you here. How are you?
Hello, Miriam. How are you? It's so nice to be with you today. I'm fine.
So what we're going to see today?
Okay, so I will start sharing my screen because today what we are going to see is how to implement an unified namespace use case, okay? What we will do is implementing this solution, this UNS solution in a food and beverage plant, okay? We will use the Barbara Edge orchestration platform to do that, and we will deploy only third-party applications that are available in our Barbara marketplace, okay?
Well, the first question will be, what exactly is a unified namespace and how does it work?
Okay, Mia, so that is in fact a very good question. UNS is something that has been around for some time. And at the end, a unified namespace solution is just a data architecture implemented in an industrial environment, which is a real-time structure and context-rich architecture, okay? At the end, we have a single source of truth for every data stream that is available in any industrial environment. So we enable the efficient data flow, we improve the decision-making and enhance the operational transparency, okay? So we can also name some of the key features that have this data structure, okay? So at the end, we have a structured hierarchy that mirrors the physical model of the plant. So it simplifies the data navigation and then the understanding of the data, okay? It is also very important that it has to be real-time and it needs to have low latency. That is something that the edge architecture enabled. So that's why we implement the UNS using edge nodes, okay? We need the data to be normalized and standardized, okay? That is why we use data model like the ISA 95, okay? Because they provide this normalization and standardization to make all the data across the different sources in the industrial to be normalized, okay? We also use any messaging solution like MQTT or Kafka that allows to decouple the data producers and consumer. So this kind of system allows to this both sides of the communication to live independently, okay? It is also very important in an industrial environment that this data structure is independent from any vendor we have, any vendor related to the physical source of the data and also to the system that use this data, okay? So again, we have also the need to live together the real-time information, but also the historical context. So we can use the data, not only the real-time data just produces, but also the historical one. It needs to be scalable and resilient, okay? We need the data structure to grow with the industrial environment and also to be resilient. It needs to be able to support any device failure, any network failure, etc. Okay, and finally, of course, in an industrial environment, the security and the access control is a must. Okay, so these are all of the key features that this kind of UNS solution have. Okay, so let's start very basically with a very basic hierarchical structure. We can see this structure here. We define like different levels, okay? So in this diagram we have here, we have defined like 1, 2, 3, 4, 5 different levels, okay? We have the field level where the devices, the physical devices, the industrial devices are gathering the information from the industrial process that we are making, okay? Then we have the line level where we get all the information for every physical device in every line, okay? The information then go to the next level, which is the site level, where we consolidate the information from all the lines that belong to the same site. And then we have the enterprise level, okay? Here we have all the information about all the sites available in an enterprise. So finally, in this top level, what we have is just this single source of truth, okay? Here we can see the nodes. We can see the edge nodes that are in every level, okay? We have like one edge node per line, as you can see here. Then all these edge nodes send the information to the next level where we have one edge node per every different site. And then finally, we have only one edge node here at the enterprise level that receive all the information together and standardize it. And then it creates what we call this single source of truth, okay? So in this case, obviously, we are going to use a simplified version of this generic architecture. We will have only one enterprise, only one site, and in this site, we will have two different lines, okay? And with different machine per every line, okay? So that is what we are going to see. To create this architecture, we need this edge node, and obviously, we need some application to be deployed in this edge node to read the information that is available in these sensors, okay? So that is why we need Barbara platform, okay? What we have here is the diagram of how Barbara platform works, what are the main systems involved in this in its functionality. But at the end, we have here what we call an edge node, okay? It is run by the Barbara core, which is the Barbara operating system that manages every edge node, and it communicates with the Barbara system. As you can see, we have Barbara panel, which is the interface that allows to manage every edge node and every application running on it. We have Barbara Marketplace. This is a shop where we have plenty of different applications to be ready to be deployed in the edge nodes. So as you can see, we live in this side of this zip plane, okay? We live in what we call the control plane. We allow to control the edge node and to control the different applications that are going to be installed in the edge node, okay? But check it, this application lives in what we call the user plane, okay? We allow the user to install this application to manage this data in the user plane. We don't live in this side of the plane, so they are like different planes in the solution, okay? We can see it better, maybe. We have here the platform that allows me to control the edge node. This rectangle is the edge node. We have the Barbara core here, but it just orchestrates the installation of different applications ready in our panel, in our marketplace, to be deployed in the edge node. Okay, so at the end, what we will do is deploying applications, okay, from Barbara panel that we create this use case. So in fact, this is what we can see in the next slide. So, well, here we have the general architecture of the application involved in this UNS use case. We can see we have the physical sensor located in the field level, okay? Here is where we connect this. We have the edge node located in the line level, and we have different industrial connectors, okay? We can use different protocol to gather the information from this equipment, okay? And then we publish this information in this MQTT broker. At the end, we have this messaging solution, okay, that also publish the information in this ParPlug format, okay? Here, we can process the information horizontally at the same level to store it in an InfluxDB and have a local database, and also have some local dashboard in a Grafana. But we can also move it northbound to the next level and to the next level to move the data until the single source of truth we have here in the top level, okay? before continuing, because we are going to implement a simplified version of the general diagram, okay, I would like to speak a little bit about what a spark plug is. At the end, a spark plug is just a communication protocol that is built over the MQTT messaging protocol. And this standard help to have a real-time data chain and the device state management. It has this feature, okay? And also, it is used as the transport layer for the UNS, okay? It provides hierarchical and context-rich namespace, okay? So at the end, we are supporting the ISA 95 data model using this spark plug format, okay? That's why we are using it here, right? So at the end, this is the architecture we are going to implement. We are going to simplify the general architecture we see before to this one, in which we had just one OpenCUA industrial connector reading the information from different machines that we have below. We will send this raw information to this MQTT broker, okay? The broker will translate this raw information to the spark plug format, so we can integrate this information with the other industrial system, okay? And we have like two different sides. At this side, we have the raw information used, okay? We have the InfluxDB to store the information and a Grafana to have a local dashboard, okay? But we bridge this spark plug broker to the next level, okay? To have all the information at the site level, and then again to the enterprise level. And we use this spark plug format to connect this information to an ignition system, have the single software tool in an ignition software, okay? So this is what we are going to see, okay? And what I propose is just move directly to a panel and see the use case implemented, okay? I have here, we have here the different nodes that are involved, okay? As you can see, we have two different lines, line 1 and line 2, okay? We have the site edge node level and the enterprise level. So just enter in this line edge node, in which we can see here in the applications and model area, we can see all the applications that are running in this edge node. We can see we have an OpenCUI connector. This OpenCUI connector has been configured to read different machines, the soft mixer, and to publish different variables like the motor speed, like the vibration speed. So this is here where we define this naming convention and this standardization of the different variables. Okay, so here we have this application reading the physical devices and publishing it to the MQTT spark plug blocker. Okay, so let's have a quick view about how the information is being published in this MQTT broker. So here we can see that at this level, I just need to copy the IP of my edge node, and then I will be able to connect to this MQTT broker and see the information, how it is being published there. Okay, so here we are. We have this information here. This is the what we call the raw format. It is not a Spark format. Okay, so we can see we have information from this line 1. We have all the machines available below. We have the dog mixer, the conveyor belt, and how are they continuously publishing this variable. Okay, so here we can see all the information in the line 1. This is what we call the raw format. Okay, and then we have here the spark plug format. It is compliant with the ISA 95. It's part of the device management, but it has a drawback. It's that this format is non-readable. As we can see, it's a binary format. So that's why we have both in parallel. We can see all the information in the raw format, but it automatically translates everything to the spark plug formats here, okay? So this is what we are publishing in this MQTT we have available in the line 1, but of course, as we saw in the diagram, okay, as we saw in the diagram here, we are also moving all the information to an InfluxDB database, and we have available a Grafana dashboard locally. So we can see locally all the information about the line 1. Let's check that, okay? I can go to this Grafana. I just need to check that Grafana is available at port 13,000. So I can open a new tab, and opening this port, I will see a dashboard, a local dashboard. It is loading, okay? So I will see a local dashboard with all the information about the energy consumption for every machine, about the temperature of the oven, the motor fuel, the DOF mixer. So I have all the information of all the machines available at the line level, okay? So now what we are going to see is we have a second edge node at the second line, okay? We have like 2 lines, and we are sending everything to this site level. In this site level, we just have a broker, okay? As we saw in this diagram, at this level, the only thing we have is a broker that is receiving everything from the 2 lines below. And finally, we are sending all the information not bound to the next level, which is the enterprise level. And here we have 2 applications. We have an MQTT Spark broker again that is receiving everything, normalize it, and then also the ignition. So let's see both of them. I'm going to the enterprise level. Okay, we have it here. And here we have these 2 applications, the Spark broker and the ignition standalone. Let's first check the information we have in this broker, okay? I will open again the MQTT Explorer so I can see the information that has been published in this one. I will put here the IP of this edge node. Okay, so now I can see that I have also the 2 information in raw and in Spark platform, but now I have the complete structure, okay? We have what we call the enterprise, we have called it Barbara, then we have the site, we have called it Madrid 01, but then we have not only the information from line 1, but also the information from line 2. Everything is converging at this point, okay? So now we have here again all the information about the 2 lines in both in raw format, but also in the Spark plug format. At this format, is sent to ignition, okay? In the ignition here, we will see we have the information about all the system below. Okay, let's open it. I will use the Vision Client Launcher. Okay, let me launch it. Okay, here we have it. So I have this application that is connecting to the ignition instance that is running in that edge node. Okay, and now it is opening. So now, okay, I have it in this screen. Let's move it here. I just need to enter the correct. Okay, so it is loading the dashboard in ignition, and we can see here all the information about the 2 lines we have implemented, okay? Yes, in fact, we have here the UNS solution in ignition, and we have the information about the line 1. You can see we have all the different industrial machine that we are receiving the variable from them, okay, with the real-time values for every of them, they are changing in real time, and we have also the line 2 information, okay? We have, for example, here sensor error in this machine, we have the different energy consumption, etc. Okay, so this is what we call the single source of truth. And as you can see, it's different. Here, this is the enterprise level dashboard with all the information in the whole enterprise. And here we just have the local dashboard in the line 1, remember, okay? Everything as we had draw in this architecture, okay? So finally, this is the simplified but complete use case in this food and beverage plant, Miriam.
Well, thank you so much, Kike. Just one question. Can we use other messaging solutions apart from the MQTT Spark flag?
Yes, of course. As we mentioned before, we need some kind of messaging solution to decouple these data sources and the data consumer, but we are not forced to use the Spark Plug solution. We have different solutions available in our marketplace. It is also very common to use HiveMQ. We can also use other solutions like ANQX or the generic Mosquito applications. It is up to you to use the one that fit better your needs.
Lovely. And so final question. So once we have a UNX architecture, how can we leverage it? What is next?
So that is also a very good question, because once we have the UNS solution implemented in our company, and it is gathering the information for every different data source we have available, it is very easy to deploy new use case that gets this information and use it, okay? So for example, we can deploy a real-time automation solution, something like a streaming analytics, something like that. It is very easy to use application like, I don't know, Node-RED or Apache NiFi that process this data and execute different action depending of the data and on the processing we made to it. Okay, we can also, of course, implement some edge AI. Okay, some edge AI solution. We can implement some different AI models at the different levels. Okay, so we can execute the AI model at the line level, just near to the source of data, and we can put it in the site level, in the enterprise level. But we can install AI models from different frameworks, as you can see. In Barbara panel, we are compatible with most of the framework available in the market that you can see, okay? And of course, we can also work, like, for example, with computer vision, something that is very common in the industrial environment. We have plenty of different applications in the marketplace that make easy to work with video data streams, okay? So, well, there is really a lot of different possibilities. Once you have all the data source together, it is really, really easy to use this data, okay?
Okay, well, thanks so much for your time, Kikel. I hope this has been an insightful talk to our audience, and we see you on the next Talk to the Expert series. Thank you so much.
Thank you very much, Miriam. Thank you very much. Bye-bye.